Welcome to the new section of understanding analytics. And in this whole section, or in this complete video, we are going to talk about what is analytics and how does it impact our decision making capabilities. So I'm going to show you a couple of the definitions, and then I also talk about what exactly analytics means, and when somebody says that he's or she is working in analytics, what do exactly they mean. So in the previous videos we talked about like what is data, what is big data, and like which all companies are using this data and harnessing the power of data, and we also understood the different aspects of data. Now let's begin with analytics. So what is analytics? Analytics is the discovery, interpretation, and communication of meaningful patterns in data. Especially valuable in the areas rich with recorded information, analytics relies on simultaneous application of statistics, computer programming, and operation research to quantify performance. Now this is the official definition of analytics, which means that if I choose some part of mathematics, some part of specifically statistics, which is called as grammar of the data, I'll pick up some part of computer programming because the data is so huge that it cannot be manually operated. I need some programming skills, and I also use some kind of operations research, and I combine that together to take out something which is meaningful, to discover some patterns, to discover some valuable insights, or I wanted to pick up something which can help me in my business. I can understand where exactly my customer are going, where exactly on what buttons people click, or what kind of content people like, or what kind of their interests are, and so much of information. If I just pick up all that information and I convert that into a meaningful pattern, I can use this for enhancing my business. So people, when they pick up this data or big data, why people want to do analytics? They wanted to interpret the data. They wanted to interpret that in a particular city, what kind of jobs people have, where exactly they go, what exactly they buy, what is their interest. Can I offer them something which can increase my sales? Can I offer some customized product to them which can increase my sales, and so on and so forth. Now I want this kind of information to be like extracted from any data or big data. Now organizations may apply statistics to business data to describe, predict, and improve business performance. Since analytics can require extensive computation, the algorithm and the software used for analytics harness the most current methods in computer science, statistics, and mathematics, which means that analytics nowadays, it is not possible without system or computers, without understanding of statistics and mathematics. So now the point is that organizations want to enhance their chances of like increasing the profit, or the chances of increasing the customer likability about their brand. People do a lot of stuff with data, and then everything is about increasing the business. And if you can harness this data and take out some information which can increase your business, there is nothing like it. And that's why the whole world is crazy about analytics right now. So you must be wondering like why people are doing analytics right now. Weren't these people doing analytics earlier? People were doing analytics earlier as well. Even 60 years back there was a lot of analytics which was going on. Even 40 years back there was a lot of analytics were going on when we did not have enough computational power. But back then the people who do analytics, or they were eventually doing the statistical computations, and in the corporate world we used to call them statisticians, not the data scientists. Now what is the difference between the data science and the statistician? That data scientists also know the programming language which can help us harness the take out the information or meaningful patterns from the data. So even this analytics word is not new. It's just that now we have digital information and the data is coming in a huge very huge space and very huge pace, then it's easy for us to do the like analytics on the basis of the computer programming and statistical techniques. Now, what kind of techniques we have in analytics and what you might have heard about, I am sure you must have heard about any of these analytics, which is like cognitive analytics or descriptive analytics or prescriptive analytics, big data analytics, retail analytics, or credit risk analytics, or fraud analytics, and whatnot. Now, these are the analytics which are used by many like corporates, but eventually they have one goal. Now, if you pick up or any of this analytics, this is eventually uh, a domain specific kind of analytics. For example, if you talk about predictive analytics, it is being used in healthcare, it is being used in banking industry or e-commerce. If you talk about retail analytics, it is being used specifically in retail, or supply chain analytics, or credit card analysis, or credit risk analytics. They've been used in specifically in BFSI domain. So these analytics, whatever name you are hearing in this whole world about the analytics, they are eventually can be classified into four parts. Any analytics in this world is gonna answer only four basic questions, and these four basic questions decides what kind of analytics you are doing. Either of the statement is true. And what are those basic questions? Let's have these questions. So these are the questions like what has happened, what happened exactly, and which is the most, I would say, lame or easy kind of analytics. How or why did it happen? Little tricky. It will just take much more digging. It will take much more efforts to find out like why something has happened, what is happening right now, what are the current methods, where people are heading, what people are looking right now, what is happening right now, what is the status right now. And the fourth question is what is likely to happen next. Now, this is more of a predictive sort of analytics which can be happening. So if you just go back to the previous analytics, for example, prescriptive analytics is the next step of predictive analytics, where you predict the alternate futures basically. So for example, if I say that let's take an example of e-commerce. If you advertise it to 100 people, then the chances are that 3% of the people will buy your product, and the profit margin would be approximately $2,000. However, if you advertise it to 100,000 people, then again 3%, 3%. I'm just like simplifying it for your understanding. If you advertise it to 100,000 people, the chances of like this 3% increases from 3% to say 4%, then 4% people might like your service and they can buy your product, and then the profit margin would be much more higher. Similarly, in healthcare, you can always say in terms of predictive analytics, that if your blood pressure and blood sugar is like this, if this keep on happening, probably somebody might get heart attack in next 1 year or 6 months or 3 months. However, if these are the inputs which needs to be changed, if somebody changes these inputs, then the chances is that he will not get heart attack in next 3 months or 6 months. And if you keep on taking that input, then probably, so basically we try to predict the alternate futures based on the input which we are offering. So there are many ways you can keep it: marketing optimization, store assortment, and stock keeping optimization. How many days I will take to sell out the complete product I have, which customer is actually going to do the fraud, and which customer is going to do the right transaction or fraud transaction. I can find out all these things with the help of this analytics. So basically 4 questions. I want you to remember these 4 questions: what happened, or why did it happen, and what is happening right now, and what is likely to happen. I'm going to answer these 4 questions, and I'm going to explain what these questions are saying. And this is how we define descriptive analytics versus predictive analytics. So descriptive analytics is nothing but the analytics of past, or I just wanted to pick up historical data. I just wanted to understand the trends. I wanted to evaluate the metrics over a period of time, and I want to identify what I have identified is true or not. Whether the patterns which I have taken from the data, are they meaningful? Are there any meaning to my organization or my product? And this is where you do descriptive analytics, which means that I'm just picking up the data, I'm understanding the trends. Either I'll create reports, or I'll create charts, or I'll create graphs, or I'll put that data into some visualization software, and I'm just explaining what has happened. The next level is called predictive analytics, which is called which is much more difficult as compared to descriptive, where I'm trying to identify the future trend. Now, you might have heard about this, right? Analytics can predict your future. Actually, it is not. It is only going to forecast the future based on the past. So whatever has happened till now, based on that, I can predict the most probable future, right? And in 90% of the cases, most probable future is actually the future. So when I say that if things will keep on happening the same way they are happening right now, 90% chances are that this is the result. And if there is no major change in the input, then 90% chances is actually your future. For example, let me give you this idea. So when you go from location A to location B, and you actually try to predict that how much time I'll take to reach from my place to airport, and it says you will reach there in 45 minutes. So your Google Map is trying to tell you, if things will keep on happening the same way they are happening right now, or they generally happens, you will reach from location A to airport in 40 minutes. However, Google might not be able to predict that if there is some faulty truck just like 500 meters away from you, and then there is a roadblock or there is a road jam. It cannot predict that. So it is not predicting the future, it is predicting one of the possible most probable outcome which can happen in your future. And then most 90% of the time, that most probable outcome is actually the future. And that's why in general we say that analytics can predict the future, right? So we go to the next level in prescriptive analytics, where prescriptive analytics is nothing but the advanced version of predictive analytics only, wherein we change the input, and based on input we kind of predict what are the alternate futures. For example, if somebody is doing exercise, then earlier he was like in danger zone of getting a heart attack, probably if he is doing exercise, he is delaying the problem. So I'm just predicting like how much time it will take to get one person heart attack, right? And I just wanted to change the input and see how much impact that exercise is making to his life, to his heart pressure and blood sugar level. So I'm trying to predict the alternate futures or alternate possibilities, I can say, and most probable or most favorable outcome. We wanted to study that what input is giving me the most favorable outcome, and based on that I change my routine, or I change my diet, or I change my lifestyle, or so on and so forth. So this is very much popular right now. It's very much like a doctorate, what doctor says, that if this will persist, this problem persist in your body, then you will face this kind of difficulty. However, if you change the input, if you take these medicines, or if you don't eat a particular food, then probably you will get better over a period of time. So this is more of a prescriptive analytics which we do. Now if you just talk about the way analytics work, and this is how the whole analytics things looks like, wherein what happened in terms of value. If you see that on the y-axis I have got value here, and on x-axis I have difficulty over here, And descriptive analytics is very low in terms of value and in terms of difficulty, because so it's one of the most easiest type of analytics which you can see, um, which means that the value is also less, because anybody can do this analytics and it's very easy for us to explain what has happened. However, if you go to the next level, wherein you call it as diagnostic analytics, where we try to answer how or why did it happen, then it's little tougher, and how the difficulty level also increases. X-axis you can see that it is going towards difficult level, and the value also increases. Now the next level we want to talk about is predictive analytics, which says that, which is much more insightful, and it also tells you what will happen if things will keep on happening the same way they are happening right now. The value of the analytics increases, also the difficulty level of that analytics increases. And the next level is prescriptive analytics, which is nothing but the extension of predictive analytics only. This is the most difficult part, and also it is the most valuable part, which keeps on telling us that what are the alternate futures and what is my favorable outcome which I'm looking for. So I hope it is making sense to you right now, right? And what we want to analyze, right? So this data, we have studied the data types, we have studied the different types of the the data. We want to analyze this data. This data is coming from almost every app, every website, every click you do on every app you clicked, every option you clicked. It's actually generating the data for you, and you want to analyze this data. And this data is speeding like anything, right? So the future growth of the data is actually staggering right now. There are billions of devices. If you compare it with the global population, there are billions of devices which are generating data. Your CCTV cameras, your smart watches, your mobile phones, your systems, and nowadays there are various IoT devices also which are generating a lot of data. So if there are like 7 billion people on earth, approximately 40 billion devices are there which are generating the data, and every device has got multiple apps. So say for example, let me give you this idea. You might be having a smart TV, or you might be having a mobile phone, smartphone. The smartphone is generating data, and also you might be having 20 apps. These every app is generating data about your browsing history and whatnot, like your location and your browsing history and your contacts, your SMSs, your call details and everything. So everything is being like everybody is generating data, and it has been assumed that in 2015 approximately 700,000 GBs of global IP data was being captured. You can imagine the amount of, and this is only IP data, okay? There's nothing, no extra data into this. It's just that only IP data is being captured. So this much of data is being captured by billions of devices, and people are buying stuff. They are throwing some mobiles away. They are having like the mobile phones which are having like 50 apps or 70 apps or whatnot, and everything is generating data. So the future growth is staggering, and then God knows like how much data we will be generating, and how much data we want to analyze. So the staggering growth is there in terms of data. Now what kind of data, in terms of, so we understand that Twitter is generating data, Facebook is generating data, YouTube, Google, YouTube, like Amazon, Pandora, LinkedIn and Netflix, Amazon Prime, everything is generating data. But if you just look for the whole sort of data, how does it look like? This is how it looks like. So we have got structured data, unstructured data. Most of the data comes in this kind of format, but even if you want to classify them like in terms of the properties, you can say that I'm using geographical data or real-time data or natural language data or time series data or event log data, network data or link data. These are the different data types which you may say based on their property. However, These all data are the types of structured data, unstructured data, or semi-structured data only. But for example, if I say real-time data, it means that though my data is unstructured, but I'm actually collecting it real time. So I need a different tool who can manage my real-time data analysis. Though I am using unstructured data, but I am actually working on natural language data. Natural language data means that human related or human interaction related data. So we wanted to have the classification of the data based on the work we are doing. So if you see somebody talking about event data or time series data, the time series data is the data which is time bound, which is having one axis as time, and the time is also being noted when you are actually dealing with this kind of data. Now again, I wanted to show you one picture which is like this. We want to pick up all this data, combine it with the enterprise data, and after picking up with the enterprise data, I wanted to stream and acquire that data. I wanted to convert them into structured and unstructured data, and then I want to do analytics on that data. This is what I want to do. Now, if I summarize this in much more easier way, this is how my data looks. My data is this crumbled data. Data is coming in all dirty format. It doesn't make sense at all. I sort that data. I arrange that data in a typical format so that it makes much more sense. And then I present that data in a very much sorted format, or I would say in a format wherein millions of lines or rows and thousands of columns will start making sense, and the result is either a report or a graph for that matter. So I can just simply say that Q1 sales of 1000 product or 1 million product is this much, and now the second quarter sales of 2000 million or 1 million product is this much, and I can present that either in reports, or I can represent that in charts, or I can represent that in terms of any graph basically. So I hope you understood like what is analytics and what we want to do. I always wanted to see the pattern. I can simply say, hey, this data is not visually appealing to me. If I give this data to anyone, it is more like a garbage. However, I can see that how much black points are lesser than as compared to red or yellow. I can compare that, right? That yellow and red are much more in sort of like in terms of equal, and they have this quarter. If this is my first quarter, this is my second quarter, then I have almost similar kind of sales and there is no improvement. However, I can say that as compared to 2018, 2019 sales were much more higher, right? So I can just visually present this data. So this is all about the understanding what kind of data we have, and I'm going to dig in deep in the next level of the very first question: what happened? How would you find out that what has happened? Now, what techniques you would be applying to identify what has happened? And the answer is, I'll keep it a secret. I want you to stay tuned with me in the next video, and I'll tell you what software, or what do you call someone, or what is the process which will help us identify to get the answer of this question, what has happened. Stay tuned with me. I'll talk to you in the next video, and I'll talk about how do you get the answer of what happened, right? So we slowly will be building the next level and into this. All right, I'll see you in the next video.